This question is IMC 2020 question 19, and it covers areas, circles. The diagram shows 2 squares and 4 equal semicircles, and you can see from the diagram that these are equal semicircles. And they have a length 48, the big one, and the inner square joins the midpoints of the edges. Therefore, we simply can find out it's half of it, which is 24 and 24. Each semicircle touches 2 edges of the outer square, and the diameter of each semicircle lies along an edge of the inner square. Then we have to get the radius of each semicircle. So first of all, we can draw on the diagram the radius. Since it's perpendicular, we know this is r, and that's what we want. And just to check the angles, we know that this is 90 degrees on each angle, since it's a square, and therefore the remaining 2 would be half, which is 45, 45. Therefore, we can find out that it's a isosceles and also a right angle triangle. Here we can find out this angle, this tiny angle here, is 45 degrees. Zoom in. And we have to prove, as you can see, you might find out that it's automatically 12 because it looks like half of the length. However, we have to prove that that's true. Let's draw it here again. This is r, and this is 24. We know that this length is equal. Also, we know that this length is r because it's the radius. And therefore, using the angles, we find out that this would be root 2r, and we can explain it by Pythagorean theorem. Since this tiny triangle is r, we know that this is root 2r. And in the same way, we know that this triangle, let's color it with yellow here. The bottom would also be this one. Therefore, we can write them as root 2r once again. And once again, to just clarify, this would also be r because it's a 45, 45, 90 triangle. Therefore, 2 lengths are equal. And therefore, we proved this point is always the midpoint. In each semicircle, we know this is midpoint of the whole length, like the hypotenuse of each triangle. Therefore, we can finally write it as the, let's label it A, B, C. Let's color in a different one because it's a bit messy. It's A, B, C, D, and E. We can prove that A, B, C is similar to A, D, E because we know that the lengths are 1 to 2, the ratio is 1 to 2, therefore we can find out that R and 24 here, this one and this one. Therefore, R would be equal to 12, and we've proven that the radius is always 12. This question is IMC 2020 question 21, and it covers areas and circles. So this diagram shows 4 semicircles, one with radius 2 centimeters touching the other 3, and those ones have radius 1 centimeters. So we have to get the total area of the shaded regions, and as you can see, it's quite difficult to just get the shaded regions. Therefore, we should think about how to minus it from the whole semicircle, since it's easier to get the areas if you split them, the unshaded areas. So let's see what we can split into. And since it's difficult to get the area of this weird shape, we would rather split it into semicircle, even quarter circle looking ones here. And now we can see a square in the middle and then a quarter. Let's write a quarter of a circle, half of a circle, and a quarter of a circle again. Then inside is just a square, and they'll be easy to calculate since we know the lengths. So let's write them up. This one has 2 centimeters, and each one has 1, therefore the inside would be 1 each. 1 and 1. So let's write unshaded region would be quarter plus half plus quarter would be back to 1. Therefore, we can write full circle. Here it's the smaller one, not the really, really big one that you can see, plus the square in the middle, the rectangle, sorry, in the middle. And therefore, we can write full circle would be pi times r squared. Here r is 1, therefore squared, plus rectangle, which is width 2 times height 1. And therefore we get pi plus 2. Now we have to subtract from the whole semicircle, which has radius 2. Therefore, shaded would be semicircle area formula would be half pi, then r squared, when r is equal to 2, minus pi plus 2. Therefore, we get half pi times 4 minus pi minus 2. And let's simplify it to pi minus 2. Therefore, it's pi minus 2. And here the answer is B. This question is IMC 2020, the last question, and it covers circles and area. The diagram shows 6 points P, Q, R, S, T, and U equally spaced around a circle of radius 2 centimeters, and the inner circle has radius 1 centimeter. We know that the shaded region has 3 lines of symmetry, and therefore we know that P, Q, R, S, and U, T would have symmetrical shapes and also same areas. So we have to get the area in the shaded region, and let's see what we can get from the diagram. So if you first see the diagram, you would find it difficult to actually get some areas that we know. However, we can use the center circle here since we've been given the radius. So let's draw some lines that I assume you've drawn on your diagram. Here, we still can't see anything that we can actually calculate. So let's draw some more, split into more space. Yeah, P, say this O, P O, Q O, R O, S O, T O, and U O. So if we actually calculate them, it would be, we can find some same areas since they are symmetrical. And let's highlight them into same colors. For example, this one here, this small triangle would be equal to this one here. And all these orange shaded areas, this one, and also the 6th one. So there are 6 triangles that we know that have same areas. Let's say this one is A, and we have 6 of them. Let's say this one here is B. Since they all have same portions of the circle, and we can tell it's 6th because they have 6 points here around the circle, and they're all symmetrical. So it would be 60 degrees for each of them, 3 of them. So we just have to get the areas of A and B each, then we can add them up later. So how do we get the area of A? This is A, and I've used P and O. P and O that we already know. We know the lengths. We've been given that the radius is 2 for the bigger one, 1 for the smaller one. We know this is 2. This one's 1. However, we don't know the length of this one. So we may have to figure out some angles if we can. Let's see if we can get this angle because it's between the two. And maybe we can use sine rule, which would use the angle between two lengths that we know. So I've drawn another one here. And we know, as I've explained, this would be 60 each because they have same angles around the circle, etc. And here I've split it into half of them. And we know that these two triangles are equal and symmetrical. Therefore, we know that each of them would be, let's zoom in, 30 degrees and 30 degrees. Now we know that from here, we know this angle is 30 degrees. So therefore we can use sine rule, easily. And if you have forgotten that I've written it here, we know that S is equal to half of AB times sine theta, which is in the middle. Let's use it here. Area of A would be equal to half the lengths and sine 30. We know that sine 30 is half. If you've memorized the trigonometry angles, therefore it will be, get rid of them, and it will be half. Therefore, we know that A is equal to half. It will be half times 6. Now we have to calculate B, and we've already known these lengths 2, because the big one. Make sure you don't forget to look at the diagram and check which radius it is. And we know that the area of a circle would be, let's write neatly, pi r squared, pi times 2 squared. However, it's a 1/6 portion of it because a whole entire angle would be 360, whereas this one is a 1/6 of it, which is 60 degrees. We get pi times by 3, don't forget, 4/6 times 3. And we get times 3, and that's 2 pi. What we get is 6 portions of A plus 3 portions of B, and the answer would be 3 plus 2 pi. 3 plus 2 pi, which is A, as you can see here. And let's check if it's correct. Yes, so the answer is A.